Hello everyone. Today's topic is AVL tree. It is also known as the height balance tree. Right? It is developed by the Adelson, Welsky and Landis. That's why it's named as a AVL tree. Right? These are the few points here regarding this tree. First one is that it is a self-balancing binary search tree. Right? It means it follows the property of the binary search tree. Second is balance factor for each node is 1, 0 and -1. It means for the each node means balance factor should be only 1, 0 or -1. If balance factor is accept these values, okay, then you have to balance the tree. Right? How you have to find out the balance factor? This is the formula. Balance factor equal to height of the left subtree minus height of the right subtree. Right? How you have to find out the height of the left subtree and right subtree? Right? You can see here in this example. Right? This is one AVL tree. Why this is the AVL tree? It is following the property of the VST. Right? You can see this is the C node. Right? A and B values are the left of the C, and X, D, E and Z values are the right of the C. Why? Because in the alphabetical order these are the right of the C and A and B are the left of the C. That's why in this way it have been inserted here. Right? Now main point is how to find out the balance factor. You can see here for this A node, right, there is no left subtree, no right subtree. It means there is no edge. So 0 minus 0, height of the left subtree 0 and height of the right subtree 0. So you can put here 0 minus 0, that is 0. So height of the balance factor for A node is 0. Okay, and same way you can find out the for the B. You can see here. Okay, so balance factor again by using this formula, balance factor equal to height of the left subtree minus height of the right subtree. For the B, height of the left subtree, right, how you have to find out the height, right, from, okay, whatever are the total number of the edges, that will be counted as a means height. So from the B to A there is one edge, so height of the left subtree is 1, and height of the right subtree there is no edge, so that will be the 0. Okay, so 1 minus 0, that is 1. Okay, same way for the E you can find out balance factor, that is 0. For the Z 0. For D you can find out here left subtree height is 0 and right subtree height is 1, because there is one edge, so 0 minus 1, that is -1. Okay, now for the X, see here height of the left subtree, there are the two edges 1 and 2. Okay, in the longest path we have to select 1 and 2. There is a two edges, so height of the left subtree is 2 and height of the left subtree right subtree is 1, because there is one edge. Okay, so 2 minus 1, that will be the 1. So balance factor for X node is 1. Okay, now for this C node, what should be the balance factor? See here, height of the left subtree, this is left subtree and this complete is the right subtree. Okay, so where you are choosing the means height, okay, then you have to select the longest path from the that particular node to the leaf node. So see here, from this particular node, for this node we are going to find out the balance factor. So from this node to the leaf node, which one is the longest path? This one is the longest path. There is a three edges, 1, 2 and 3. Okay, so we will consider this path. Okay, and height of the left subtree, that is there is only two edges. Okay, so this is 2 minus 3. This is again I am telling, for the left subtree height is 2. Why? Because there is only two number of the edges and this is the only longest path, so height of the left subtree is 2, and height of the right subtree, this is the longest path. This longest path you have to select. Why? Because always longest path will be selected. So there are the three edges 1, 2 and 3. So height of the right subtree is 3. 2 minus 3, that is -1. Okay, so this is the balance factor for the this root node C. Now you can see balance factor is only 1, 0 or -1 for the each node. Okay, if balance factor will be changed, right, again I am repeating, if balance factor will be changed, suppose for this node, after the calculation you are getting the balance factor 2 or any other value, then you have to balance the tree, right, by using the these rotation techniques, there are the 4 rotations, okay, for the balancing the any AVL tree, right? Sorry, fourth point is here, every AVL tree is BST, but every BST need not to be AVL tree, means all AVL tree is a BST because it is following the property of the binary search tree, but every BST need not to be a AVL tree. BST is not, it is not compulsory that all BST will be the AVL tree, right? So these points you have to remember. Important point is balance factor, how to find out the balance factor, height of the left subtree and minus height of the right subtree, right? Here I have told how to find out the balance factor. Now see here, if any node is not balanced, means that is unbalanced. How it will be the unbalanced? Okay, if values of the balance factor is other than these values, means value is not belong to the this one 1 0 and -1, then we have to balance the tree. How you have to balance? They are, see here, this fifth point, 4 rotation is used to balance the AVL tree, right? These are the first one is the left rotation, second is right rotation, third one is the left right rotation, and fourth is right and left rotation. Okay, first see here, first left rotation. When such kind of the condition will occur during the inserting of the node into the AVL tree, then you have to apply the left rotation. See here, suppose first node you have inserted 1, after that you are inserting the next value, that is the 2, and 2 is greater than 1, that's why it will come right side according to the BST property, right? Again you are inserting a third element, that is 3, right? And 3 is also greater than 2 and 1 also, so it will come the right of this. Okay, and after inserting these nodes, right, situation is like this for the each node. Find out the balance factor by following this one. For the 3, balance factor is 0. For 2, left subtree height is 0, height of the left subtree is 0, height of the right subtree is 1, so 0 minus 1 1. For the 1, height of the left subtree is 0 because there is no left subtree, and height of the right subtree, there are the 2 edges, so height of the right subtree is 2, 0 minus 2, that is minus 2. Now you can see here balance factor is minus 2, right, for this node. Okay, this is balanced, this node is balanced, this node is balanced because this is minus 1 0, it belongs to here, but minus 2 doesn't belong to here. Okay, value should be only 1 0 or minus 1. Okay, so we have to balance this tree. In the left rotation, if situation is like this, means nodes have inserted in the right of the root node. Okay, so what you have to do, apply the left rotation, means you have to rotate this side, left side. Okay, you have to rotate the left side. After rotating left, what you will get here, you can see when you are rotating your left side, 2 have been reached here on the root node. Okay, now 1 have come here and 3 is here. Now find out the balance factor again. For 1 0, for 3 0 by using this formula. Okay, for 2 also 1 minus 1 0, so now it is balanced. Okay, so if any, you have to remember this condition. This is the first case. If this case will occur, then you have to apply the left rotation. Okay, now see here, right rotation B. In the right rotation, if you are inserting the number 3 to 1, okay, first node is 3, you have inserted, again you are inserting the number, any node, that is 2, that is the 2 is less than the 3, so it will come the left of the this one. Again you are inserting 1 and that is less than the 2 and 3, so it will come left of the 2. It means when you are inserting means any node, okay, in the in the AVL tree, and you are getting the this kind of the situation, means nodes are all in the left side. Okay, here all nodes are on the right side, so apply the left rotation. All the nodes are in the left side, so apply right rotation. Okay, again you can see for the 1, balance factor is 0. For the 2, balance factor 1 minus 0 1. For 3, balance factor 2 minus 0 2. Okay, when you are applying the right rotation, after rotating you are getting this tree. Okay, 2 have come here, 1 left side and 3 right side. For each node, balance factor is 0, so now this tree is balanced. Okay, same way, this is the first case, this is second case. Third case is LR rotation, means left rotation then right rotation, means this is the double rotation, these two are the single rotation, right? Left rotation, right rotation means if such kind of the situation will occur, then first you have to apply the left rotation and simultaneously same time you have to apply the right rotation. Okay, means two rotation will be applied, okay, same time. How, see here, suppose you are inserting the first node, right? After inserting the first node, next node when you are inserting, that is coming into the left, okay, and again when you are inserting the next node, then it is coming to the right according to the BST. Okay, so this is the left and right, left and right. So when this situation will occur, left right situation will occur anywhere during the insertion, then you have to apply the LR rotation, means first rotate this left, after that rotate the right, rotate this left after the finding the means BST, sorry, balance factor for each node. For 2 0, for 1 for this node, 0 minus 1 1, for 3 2 minus 0 2. Okay, first apply the left rotation, this is the left rotation. After rotating this, 2 have reached here and 1 is here, right? Again apply the right rotation. Okay, when you are applying right rotation, you can see you are getting the this tree, and this tree is the balance tree. Okay, so in the what is the, in the third case, if you are getting the this case L and R case, means after the first node, second node is in the left side and third node is right of the second node, this one, this situation, then apply the left rotation and the right rotation simultaneously. Okay, so this, in this way you can balance the tree. Okay, and next, fourth case is RL notation, right? RL notation, in this case what you have to do, see here, first node is this one when you are inserting in the AVL tree, and second node is coming right of the first node, and third node is coming left of the this second node, right? Means situation is right and left. Okay, when you are getting the such kind of the situation, again you, when and you are finding the balance factor for each node, right? So for this node balance factor is 0, for this node 1 minus 0 1, and for this node 0, left side balance factor 0, right side this is 2, so 0 minus 2 minus 2. Okay, so minus 2, this doesn't belong to this one, right? 1 0 or minus 1, so it means this node is not balanced, this is the unbalanced tree. Okay, to balance this one, first apply the right rotation. After applying right rotation, okay, when you are applying right rotation, this is the next step. See here, 2 have come here and 3 is here, right? And position of 1 is here only, and after that apply the right rotation this side. Okay, don't be confused by using this arrow. Okay, by mistake it have been put here. Okay, this is the right rotation this side. Okay, so after applying the right rotation this side, okay, you will get the this BST. Okay, again you can find out the balance factor for this node 0 0 minus 0 0 minus 0 0, for this one 1 minus 1, height of the left subtree 1 minus height of the right subtree 1, 1 minus 1 0. So by using this you can balance the tree. So you have to remember, when you are going to insert the elements into the AVL tree, first during the insertion you have to follow the property of the BST. What is the property of the BST? Means all the values in the left subtree should be the less than the root node, and all the values in the right subtree should be the greater than the root node. Okay, so by following the BST you can insert all the elements into the AVL tree, and during the insertion you have to find out the balance factor by using this formula, height of the left subtree minus height of the right subtree, right? And for the each node, balance factor should be the only 1 0 or minus 1. If balance factor is accept these values, right, then you have to balance. How you have to balance? By applying these 4 rotation. Okay, left rotation, right rotation, left right rotation, and right left rotation. Okay, So by using this one, right, you can construct the AVL tree. Okay.